Hi all, myself Vidhya Vijayan, Assistant Professor, Department of Software Development. Today we are going to discussing about an important property that is called ACID property from the database. Okay, in this class we will discuss about database and what is ACID properties and some functionalities or examples of database ACID properties. In the introduction part, or what is database or what is database management system? Database is a collection of related data, and database management system will manage these kinds of database. Okay, the system which is used to manage the database is known as database management system. As you can see, management of data is database management system to maintain the integrity of the data. There are different kinds of different related data are in database. So we need to make these kinds of data, or we need to maintain its integrity of this kind of data. So we will use a property for properties, that ACID properties. It can be named as ACID properties, ACID properties. Okay, ACID means atomicity, consistency, isolation, and durability. ACID properties means atomicity, consistency, isolation, and durability. We can discuss each and every topic. Atomicity, as the name indicates, the data should be atomic. That means, suppose I am trying to send, or I am going to done any transaction like sending some values, sending some data to one system to another system, or one system to another system. The data should be atomic. That means if any operation is performed on the data, either it should be performed or executed completely, or should not be executed at all. Suppose I am applying any operations, or I am performing any kinds of applications, any kinds of functions, methods in one data, it should be done completely, or it not to be executed at all. That means the operation should be completely executed and not partially. So if I am doing some problems, it should be done completely, not partially. This is known as atomicity. That means it should be done. Atomic means it should be done completely, or not. Okay, as you can see this. It's an example for transaction. That means I have two accounts like A and B. Here A have value, some value, value like 30, and B have 100. Before transaction, this A have 30 and B have 100 as values. Suppose I am going to transferring data from A to B. What will happen? I am going to transferring 10 rupees from the account A to account B. What will happen? 10 the rupees 10 will be debited from the account A, and it will be credited to account B. So the current available the cash of account A will be 20. That means 30 minus 10 equal to 20. And in B, we know that 100 plus 10. That means it is credited by 10 rupees. So 100 plus 10 equal to 100. But you can see here 110. But you can here you can see the available value is 100. What happened here? You can see here debited successfully, but credit failure. That means here a partially execution happened here. So when I transfer the data from A to B, the debit process done successfully, but the credit process got failed. So we can see that available value is the previous value called value, or rupees, that is 100. So what happened? It is known as partial execution. There is no atomicity because the transition is partially happened. So execution termination happened in the credit portion. Okay, so it is not atomic. This transaction is not atomic. So we can go to the next example. Here you can see before transferring the data, the value is 30 and debited value is 10. I am going to transferring 10 to account B, and the available value will be 20 because 30 minus 10 equal to 20. In B, we can see before transferring the or getting the credit the value 10 from the account B, the previous value is 100 and the credit value is 10, available value is 100 plus 10 equal to 110 rupees. So debit successfully happen and also the credit value success process is also successfully happened. So transfer process done perfectly, and also we can say that complete execution have done. This is known as atomicity. That means the process completely happened without any failures, without any problems. So execution successfully completed. This is an example for atomicity. Atomicity. Second property is acid property, ACID. The second property is C. So C means consistency. Value here, the value should remain preserved always. As you can see here, the data consistency means you can see there is account A and account B and C. I am going to transferring some cash from A to B and C as this B and C, from A to B and C. So you can see before transferring the data, the account, the value of A is 300 debit. If I am sending value to B called 50 rupees, if I am sending 50 rupees to B, the available value will be 250 because the value debited to B, that means the value of A is decreased. So when I am when the value read by B, when the value read by B, then the value will be, what will be the value? 300 will be the value. Okay, you can see before transaction, we can see the value 300. Okay, B, you can see before 100, before transferring the data, the value as 100 and the credited value will be 50 because the 50 rupee is sent from A to B, and the available value will be 100 plus 50 is equal to 150. In the case of C, the account C, here we can see before transferring or any transaction happens, the value will be value is 50, and I am sending 20 rupees from A to C. What will happen? Credited value will be 20 and the available value will be 50 plus 20 equal to 70. If I am if the C reading the value of A before going to the transaction, what will be the value? 250. So we can say that there is a data consistency because when before transferring the value or cash, the B just read the value. So it get 300 rupees, and when before transferring the value, C already read the data, it is known as 250. So these are different values. So we can say that there is a data consistency. There is a data consistency in the transaction process. Third one is RC properties. Third letter is I. So isolation. Isolation means separation. We need to separate these each and every value. No data should affect the other one and may occur concurrently. That means the operation on one database should begin when the operation of the first database gets complete. The definitions are same. As you can see, if two operations are being performed on two different bases, they may not affect the values of one another. Suppose I am executing or I am doing some operations in two different databases. It should be preserve, or it should not affect one database on another database. Okay, they are separated. There will be a separation between this database. So if I am applying one operation to one database, it should not affect the second one. Okay, we can go to an example. Here you can see transferring, there is a transaction T1 transaction and T2 transaction. A will send a value to cash to B, that is known as T1, and the T2 will be T2 is the second transaction. That means the value will be sent from A to C. As you can see, before transferring the data from A to it's not data, it's cash, A to B, before the value was 100, the debit, if I am going to sending 20 rupees to B, it will be credited from account A, that means 20, the value is 20. The B will be the before transaction or before any process, B value was 50. So credited by A will be 20. So 50 plus 20 equal to 70. Okay, value read by B before T1 was 100. As you can see, the before this transaction happens, what was the value of A before values? That was 100. So second transaction is T2. Here you can see I am sending 20 rupees to, if I am I am going to send 20 rupees to C. So what will happen? The previous value was 70 plus 20 equal to 90 will be the value. Value read by C before T2 was 80. Here we can see value read by C. That means C will be read the value of A, that will be 80, because the available value before T2 transaction was 80. So we can say that there is an isolation. That means transaction T1 is not affecting T2, or T2 will not affect the is not affecting the T1 transaction. So we can say that it's an isolation, independent execution of T1 and T2 by A. The T1 transaction is not affecting T2, and T2 is not affecting the T1 transaction. This property is known as isolation. And the last one is durability. Okay, what is meant by durability? Means durability ensures the permanency of something. That means permanent data. Suppose I am transferring any data, durability ensures that the data after the successful execution of the operation becomes permanent in the database. That is known as durability. Okay, if the system fails or leads to a crash, the database still survive. That means suppose my system got any hang or any failures happen, the durability process say that the system after performing any operation in any data in the database, the data will be becomes permanent in the database. If any loss happens, the responsibility of recovery manager is to ensure the durability of the data. What all are the things we discussed in today class? We discussed about database, and we discussed about some ACID properties which should maintain the database management system, and some examples and some functions of these kinds of examples with these kinds of properties. That's all about today. Thank you.